Thank you everyone for joining us, whether you're in person here at the University of San Francisco or whether you are online. Today, our speaker is Funmi Doro at Spotify, who is an engineering manager. And today she'll be talking about model evaluation. So Funmi, please take it away.
All right. Hello. Good afternoon, everyone. I hope you hear me fine. Do you hear me?
Yes, sounds great.
Okay, great. Okay, I'm going to kick us off. Thanks so much for the introduction, Victor. And yeah, I'm here to chat with you about model evaluation. And quick introduction to who I am. I'm, like Victor said, I'm an engineering manager. I work on the ML platform team at Spotify, and our mission is to empower ML teams to build ML-powered products faster, responsibly, and more collaboratively. And just a little bit about my journey, because I think this will be interesting for some of the folks that are students at USF. So I started out as a software engineer, and actually at the time I was a software engineer, but today many might refer to me as a data engineer because I was building prepaid and postpaid billing systems for the telecoms industry. And then I decided I wanted to make a change. I wanted to learn about data science. So at the time I applied to USF and I attended this program. It was amazing, 1 year. It felt very intense. It was an intense 1 year, but at the end of the day, I was able to make very rapid transitions, first as a data scientist and then very quickly to an ML engineer. Yeah, and I would say the difference between a data scientist and ML engineer, at least at the time, was that ML engineers could essentially productionize their own systems, could ensure that they followed the ML system throughout the entire life cycle. And then eventually, because of my background as a software engineer, I eventually quickly transitioned into being the ML infrastructure engineer on my team as well, building tools to support other data scientists and ML practitioners at the company. And then eventually I transitioned into leading data and ML infrastructure teams. So yeah, it's been a wild ride, and I think it's this is an area that I'm very passionate about. So I'm constantly excited to learn about the trends, and I want to share some of my experience, particularly around model evaluation. So so the agenda for today is I'll give you a little bit of introduction and some context for the problem, and very quickly describe approaches to adapt agile lean methodology to ML development lifecycle, and then share a few tips with you all. So, like, quick disclaimer, all these are my own opinions. I've actually not really had the time to check it out with anyone at Spotify. So Spotify, these are not opinions, Spotify's opinions. And also my opinions are open to change. I'm still learning and evolving myself. And also this is my first attempt at this talk, so I've not gotten lots of feedback. So I appreciate any of your feedbacks. Also, you can DM me on Twitter. So quick introduction. So this is a recurring pattern from my own experience and from the experience of folks I've spoken to, many ML practitioners that I've gotten the opportunity to speak to in the last couple of years. So this recurring pattern is where there's some business executive that gets really excited about the potential impact of ML to their business, and they invest in hiring a team of ML practitioners. And then the ML practitioners as well feel very excited. They buy into the hype, and they feel the need to prove that ML works. So they spend many months perfecting a model for production. Like they're doing all of this oftentimes offline. They are not testing this. And then eventually there's some day after many months of work where they get to deploy this model to production, and then find out that it doesn't actually meet anyone's expectation. Oftentimes it doesn't even meet their own expectation. They have this expectation that the model is going to, increase user engagement, it's going to solve some problem, it's going to be a recommender system that helps users find and discover stuff they didn't even know they wanted, stuff like that. So ML practitioners are making a lot of this, setting these expectations for themselves and for their stakeholders without a lot of evidence. So this is a recurring pattern, and actually this is something that's happened to me. So I'm talking from experience here. So everyone gets excited, everyone feels it's gonna be amazing, but it doesn't turn out to be this way. And so Gartner did a number of surveys, and also I think based on the surveys projects that even through to 2022, only 15% of ML and AI projects will be successful. So they had this initial report where they've been tracking some numbers and found that staggering 85% of AI projects fail. So, and I actually spent some time reading like some of the responses to some of the reports, and oftentimes the top problem was, oh, it was the wrong problem. Maybe this problem was actually not very well suited to ML, or maybe it was like really poor requirements. Oftentimes everyone's like, oh, the data quality was really low, or maybe the ML practitioners did not collaborate well with the business stakeholders, or the ML practitioners lack domain expertise, or even the very common one, the ML infrastructure is too complex. Production infrastructure is too complex. It all works, but just the process of trying to make it deploy to production is where we get stuck. And in my experience, this is the impact. And actually, maybe I've spoken to a couple of people about this as well. So oftentimes you're on the team and they're like, oh, maybe you don't know what you're doing as an ML practitioner. Maybe we need to get someone more senior in here to to fix things. And then sometimes the project get canceled. Sometimes if you work at a startup, the startup will run out of money. And I think the one that is really sad is actually that ML practitioners just lose confidence. I think this one is my experience. I felt at some point, I felt like, oh, wow, I was a very successful software engineer. Is this really something that I should bet my future on, if I was good at something and I'm trying out this new thing. So, and I think this is really sad. And this is the thing that motivates me to be an ML infrastructure engineer, building tools that help ML practitioners feel confident that they're going in the right direction. So I think the funny thing is, as a software engineer, many years ago, this was almost the exact same thing that was said about software projects. So, I mean, like, I actually went back, there's this reference, and I looked at the top reasons why software projects failed, like maybe 10, 20 years ago. And it was exactly the same reasons, not collaborating well with the business stakeholders, not knowing enough about the business, not understanding the requirements. It was exact same set of reasons. And it just felt like deja vu, like, why do we keep repeating the same issues? And in my opinion, like, just following the progression of as a software engineering practitioner, like, I believe there's a key gap. Of course, the infrastructure gap is a gap. Like, there's so many ML frameworks, there's a lot of complexity, but actually the ML product development process and methodologies around this is probably one that can be better adapted to suit some of the challenges and the risk of making lots of assumptions that are not validated. So actually there are two separate set of methodologies, the agile and the lean, but oftentimes many people use it together, and at Spotify we actually use it together. So the key concept with agile is that it's an iterative approach to software development, and it's essentially that every sprint you're having some working software that you're deploying to production, and there's no prescribed duration of what the sprint should be, but it's typically around 1 to 2 weeks in most companies. And And the idea is that you don't trust your requirements and you don't trust your plans. You're trying to basically evaluate and learn continuously and have the ability to be agile and respond quickly to change. And in contrast to software development projects before agile were always waterfall. So you have like year-long projects that would be deployed to production at the end. So very similar to what we do with ML projects now. And then there's also this lean methodology, and it's very similar to agile methodology, but it really stresses this idea of you want to rapidly discover whether this idea or this hypothesis is viable. And the way to do this is you have an idea. For example, with us, maybe you're trying to apply ML to a problem. You quickly build a prototype, and then you experiment. You run A/B tests, and then you get some results, and you analyze the results, and then you validate whether you're on the right track or not. And there are some key concepts here that are very important to the lean methodology. One is that you have actionable metrics. So these are metrics that guide the actions and the decisions you make with regards to how to proceed in iterations. And then a concept of A/B tests where you're having multiple versions. Oftentimes it's called A/B tests because sometimes it's 2 versions, but it could be 3 versions of a product, and you're offering that to customers so that you can decide. You can measure the impacts and make decisions on which one drives the most impact. And then the other concept is the concept of an MVP. So an MVP, this is very popular concept, minimum viable product. But in this is more, an MVP is a product that allows you maximize your learnings with the least efforts. So you're building just enough to learn. So and really this system, I believe, can be easily adapted to the ML product development lifecycle. And I've seen it being adapted well to the ML product development lifecycle at Spotify. So the idea is that, yeah, we have the ML product development lifecycle is actually very well aligned. So it's very common to see there's a problem definition, there's data and feature preparation, model development, model evaluation, and then some production deployment and maintenance. But the idea is that the problem definition is where you are really investing some time trying to learn, and then you're building, and then build is all of the feature engineering, model development, data collection, all of that is the build step. And then evaluation is where you're measuring, and then also in production, while you're monitoring, you're also collecting data to measure and monitor that the model continues to perform as expected. And I think the build steps are quite clear, but specifically, I want to stress the problem definition step. Because typically, when you're just starting out, you have some key hypotheses that you're trying to validate, and that's what you focus on in the first iteration. But in subsequent iteration, now you have lots of data from the measure step, and you're looking at that data, and you're trying to find out, if your previous iteration was a successful iteration where you're moving some metric. You're trying to understand why was it successful? Could I even invest more in getting more success based on that evidence? And then if it wasn't successful, you're trying to understand why, and actually understanding why could inform the priorities for the next iteration. So that's these problem definitions. And when we talk about objectives for the next iteration, the objectives, there's this process or like established process, which is objectives key results, OKRs, where you explicitly, based on data, set objectives. Like I believe that an example of this is I believe we can move like monthly active user if we build a recommender system with this amount of accuracy, for example. You set up that hypothesis and then that's what drives the entire iteration. So you build, and then I also want to stress the measure step. So the measure step is really using evaluation metrics to understand the performance of a model, particularly to understand the strengths and the weaknesses of a model. Like who does this model work for? In what situations does it work well? And in what situations does this model fail? And so with adapting this ML lifecycle, incorporating agile and lean methodologies about, closing this loop as many times as possible in a short time, making some assumptions, validating that this ML is a viable solution for this problem, mitigating the risk that, that you will overinvest by building the minimum viable products, actually at every step, at every iteration, the minimum viable products. So that's one. And then, and I want to share a couple of recommendations now that in my experience helps apply this agile lean methodology to ML projects. So the first recommendation is embrace heuristics, and this is really based on a lot of feedback. Like this is something I felt when I was an ML practitioner and also managing ML teams myself. I think everyone is always like, ML practitioners I talk to, they're always so paranoid. How do I ship my model to production? I literally looked at the numbers. The numbers don't look good. Like it doesn't work in this scenario, that scenario. I know this model has gaps. I don't want to ship my model to production until it's perfect. And yeah, how would anyone even trust that I'm a professional if I ship this kind of model to production? And I think the assumption here is that all models have to be machine learned, and your entire ML system has to be a machine learned system. And I think the challenge here is to think about how can we apply heuristics to ML. Like, so first of all, heuristic is defined as like a mental shortcut commonly used to simplify problems and avoid cognitive overload. These solutions may not be optimal ones or are often sufficient given limited time constraints or time frames and calculation capacity. And so models could be ML models, or it could be a heuristic model. And oftentimes, like if models make decisions, it's possible to have a model that is based on hard-coded rules that also makes really good decisions. And because oftentimes actually heuristic are based on manual analysis of historical data. And basically the rules are data-informed rules that have been hard-coded. And then, but yeah, of course, it's nice if we could have ML models make great decisions in every scenario, because yeah, this is ML systems. The idea is that ML system can come up with a lot more complex rules that work well, even though they're not explicitly programmed to do so. But the challenge here is that as an ML practitioner, for us to try to be more iterative and more agile and more lean, we would need to consider not always having the ML model be what we ship in every iteration, or maybe shipping a combination of ML model and heuristic model. So, and I actually don't think this is a controversial take. I think many people say start with heuristic And everyone says starts with heuristic. That's not controversial. I think the thing that folks don't talk about is actually you can continue with heuristic. Like you don't need to after you've shipped the first version that is a heuristic, you can keep using heuristics in all the subsequent versions of your models. And actually, many teams do that. And I don't really know why many people don't share this. Yeah, so many teams would use heuristics, and they would even use human in the loop approach for shipping models to production with all the time constraints. And I think the question is, when do I use heuristics? And the general rule is that you need to really have like a very rigorous model evaluation system that helps you identify the gaps in your model and have very targeted heuristic that overrides the decisions made by your model in the situations where it doesn't meet the requirements. So another thing is, another key insight is that even the most advanced ML systems have heuristics. I think some systems they call it like a policy layer. Even at Spotify, I believe we often call this a policy layer, where there's some heuristic layer that is a part of a lot of ML systems that ship to production. I will try to get these slides shared with Aya or Victor, but I have some links here to some material that describes some of this in detail. So, and the other thing is that actually looking here, one other takeaway from this slide is that the ML model, or it's important to think about the ML system and not just the ML model. So in this case, the ML system encompasses like even this candidate generation, and the candidate generation is a heuristic oftentimes. So like if you're trying, I think this blog was about the Pinterest home feed. And yeah, how do you determine what should be ranked? You can't rank all of the pins on Pinterest. So you need a way to simplify the problem and have some simple algorithm that would generate like a few candidates. Oftentimes these are heuristics as well. So designing your ML system, thinking about how to incorporate heuristics strategically across the system and get something that works out very quickly is very important. So the other recommendation is to think more about business metrics and not just model metrics. So like during the program at USF and in a lot of blogs and books, oftentimes ML practitioners get very familiar with model metrics, things like accuracy, recall, precision, and all of these metrics. And while these metrics are really good and help you understand the progress you're making towards your modeling efforts, they oftentimes don't help you understand how much your model would improve user satisfaction. Like there are lots of assumptions that are made in model metrics that oftentimes cannot be validated just with model metrics. So it's really important to think about business metrics. So this slide shows there's this HAT framework that was developed at Google that has many types of metrics that you can use to evaluate your models. So oftentimes it's like, I know at Spotify, we use surveys to evaluate how well our models are performing. We interview people, we do like user research. All of these are good measures of understanding the impact that your models have on users. And also like, do users actually engage with this, with your product? And like, do you want, is your hypothesis that users will engage more with your product? because of your model. Like you need to think about this and understand the relationship maybe between your model metrics like accuracy and how much does it increase the likelihood of users returning to your products. Like for example, it might actually be in your business interest for the user to spend maybe quite a bit of time on your homepage, scrolling and exploring the app. Maybe that's a business goal, and overly optimizing for having the right the right first prediction of right first recommendation might not be a goal. It might be more important that you have a good diverse lists of recommendations. Like that could even inform what sort of business, what sort of model metrics that you pick. Like for example, for for recommenders, usually there's metrics that assume that ranking metrics like NDCG that assume that the business objective is to minimize the user from scrolling. Like, so having the user click on like the first one is yeah, you penalize the model oftentimes based on how far in the list the user clicks. Well, is that the goal of the business? It's really important that ML practitioners, as well as all of the stakeholders, align on what business metrics you're optimizing for. And the other thing that the other reason why business metrics is really important is that it's probably the most effective way of evaluating the entire ML product. Like, it helps you answer questions like, for example, this is my Spotify homepage. Like, should we have 6 playlists here, or should we have 4? Should we invest in pictures? Are users more likely to click on episodes that have pictures, or do they only click on pictures when there's a famous person on the home page? Should we default to the logos, or should we try to get our content creator to send us photos, stuff like that? Like, some of those things are things that might be cheap to invest in for your company relative to improving the model. Yeah, and also in this case, business metrics help you understand how do this, as Spotify, these are 2 separate systems. There's a music recommender system and there's a podcast one. Like, are there interactions between these 2 models? Like, would users almost always not scroll through the podcast shelf if they find a really good recommendation on the music shelf? Questions like that you can only ask with a business metric. Next slide. And then the third recommendation is that offline experiments don't offer validated learnings. So one of the Lean principles is that you want to have validated learnings. And one thing that is very common in industry is for teams to feel like we're agile because we experiment quickly. And in this case, experimentation is considered, we're only considering offline experiments. So you're doing problem definition, data and feature preparation, model training, offline evaluation, and then you're closing the loop by starting over to problem definition, but you're actually never shipping anything to production. So I think it's important not to consider that as a full iteration. There's value in optimizing, performing rigorous like hyperparameter tuning, and trying to select the best model for production, given some time constraints, but you don't want to overinvest on just offline iterations. And here's why. So online experiments help you really compare 2 model variants based on, like a more rigorous process called A/B testing. And this is something that almost all ML models at Spotify perform before they deploy their models to production. So A/B testing helps you compare two versions, and then you're testing, this is subject, but you're testing the user's response to variant A versus variant B and determining which variant is more effective. And the other thing about online experiments is that oftentimes online experiments is the only way to get at business metrics. So offline experiments, oftentimes you can estimate business metrics, but you really can't get accurate business metrics. So offline experiments help us do roughly the same thing, but the model variants are compared using historical data. And there's an assumption here that, you know, like the user's historical preferences will continue in future. And oftentimes it's correct, but there's the reason why we believe that metrics that you compute offline are just proxies and estimates. Really the goal here is to not overinvest in offline experimentation, but invest just enough to proceed to the online evaluation phase and move into production. So yeah, A/B testing and online experiments are really the gold standard. You really don't want to spend too much time doing just offline experiments. And I think many ML practitioners, they have this assumption that there's some correlation between some metric that they're seeing offline and a business metric that they're seeing online. So the idea is that I can continue investing in offline experimentation because I'm seeing my metrics continue to increase and increase. And really, this is a big assumption that this would translate in production. That this means that a metric like monthly active user is also continuing to increase. But I think this is not a wise assumption to make. You really should validate this in by testing in production, because oftentimes there's actually from some of the user research we've done with our users at Spotify, they often run into many situations where they see they have a model that completely outperforms any model they've ever seen, and then when they ship it to production, doesn't have the expected impacts on business metrics that they expect. So in conclusion, I would say manage expectations with quick experiments and actionable metrics. And yeah, I think that's the end of my talk. I'm happy to take as many questions.
Thank you very much. Now we'd like to open the floor to speakers here at USF or anyone online. You may ask your questions and we will see them in the chat and ask directly from there. Please make sure that mic is on. Yeah.
Hi, I really liked your talk today. I wanted to ask quickly about testing models like the online portion. You mentioned that you use A/B testing, and I think that's great, but I also wanted to ask about AA testing, because we had a speaker, I think last week or the week before, that mentioned that they did A/B testing and A/B testing and applied it to their model, and the metrics were good. But then after putting it into production, it didn't work out as well. So they came up with using AA testing as a way to sort of reevaluate the metrics and came up with something a little more comprehensive. So I wanted to ask more or less your opinion on it, and if Spotify uses that as well.
Well, yeah, thanks for that question. I'm not sure about AA testing and how it could help with metric selection. I think overall, in situations where we find that you will expect that if you do an AA test, if you have a good system for doing A/B testing, good infrastructure for A/B testing, the outcome should be the same. Yeah, so the business metrics should be exactly the same. So my assumption, very naive assumption here, is that if you see like business metrics for an AA tests where the two variants end up having different different outcomes, it might be a bug. Yeah. And actually we use this at Spotify quite a bit, sometimes to test our infrastructure, to see if we actually have a good randomization system, if we have, test bugs in the infrastructure. But yeah, I might need to ask some more experts. But the thing that we do to test whether we have the right metric, particularly to validate whether we have the right metric offline, is there's this set of tests called online offline correlation tests. So the idea here with some of these tests is that you're trying to test as many models as possible, oftentimes maybe like 10 models, and you see that these models have different there's a lot of variance in their performance, and maybe you're using multiple different approaches. Maybe you're using a simple boosted tree, you're sometimes using a reinforcement learning, and the idea is really to calibrate your metrics to try to understand calibrate your metrics and to understand the sensitivity of metrics. So is for example, some teams might want to use a metric like lifetime value. It's a metric we use at Spotify, but that metric oftentimes might not be sensitive in some problems. Like you are almost never able to move that metric. So okay, I probably shouldn't use this metric because I tested many different models and the metric almost never moved. So it's used more as a calibration system, but it's not an AA test.
Thank you. And we have more questions from the audience. Go right ahead.
Can you hear me okay?
Yes, I hear you okay.
All right. So I really liked your talk. I'm a big fan of lean methodology. But the situation, and for a lot of us, like in this room at USF, we're like just starting out. So my concern is like, when we get into a data science position, like usually like those sort of methodologies are kind of like in place already for the team, but how can like a person new to the team try to like encourage the use of this methodology or like make it a part of their process, even if we've got some sort of a system in place already?
Oh yeah, yes. I'm hoping many more companies follow this approach, particularly for their software development systems. Yeah, that's a tough question. I think if I were to start a job, just thinking about what I would do, I'll probably just ask so many different questions. Like if you tell me to ship some models, I'll be like, how do I know that? How do you know that this is gonna? What business impact do we want to drive? Like just thinking about the Spotify homepage, I'm just thinking about maybe the first set of ML practitioners that were asked to build the home recommendation system. I think my question would be like, how do you even know folks want to go to a homepage? They probably know what music they're going. they probably know what music they want to listen to when they come to the Spotify app. Why should we build this system? Why don't we just build a better search system? I think those questions generally, and that staying skeptical is what helps businesses understand that actually we don't have the answers, so we shouldn't build this system first. We should really maybe just have some very naive system that shows you some trending tracks on the homepage and see how folks engage with that. Yeah, I think that would be the approach I would try. I don't know. Yeah.
Do we want to? Yeah, so we'll go ahead with 2 more questions from the live audience, and then we'll start transitioning to the Q&A on Zoom.
Hi, I also had a question similar to the previous question. Lean is generally used in the more traditional industries like manufacturing and production. And so I was really surprised when you mentioned that you guys use it as a combination with agile methodology. So I was wondering if this is something pioneered or implemented by Spotify, or do other companies use this as well?
Yeah, thanks for that question. Yeah, I think I've seen this done really well at Spotify, but I think many companies would say they aspire to do this. I'm not sure, at least the previous companies that I've worked at. And yeah, I think the difference I would say between companies that aspire to do this and the companies that really do it well is how they staff the teams. So let me see if I'm trying to say, so for example, I asked about trying to think about all the possible ways you could optimize this system. Like, should you get better pictures? At Spotify, we really think about teams that include folks that could do that could, like, the organization is set up such that all dimensions of the problem can be optimized at the same time and with every iteration. So we're not, oftentimes when we're thinking about a lean system, a lean agile system, it's not always that the case that it's just ML practitioners just building the system in isolation, or yeah, there's really an organizational setup that supports, making the best decisions with each iteration and really being agile enough to change your strategy. Yeah, and not having, yeah, imagine if you found out that the heuristic continues to work. I think sometimes it might not be in the ML practitioner's interest to have that be an outcome, but I think that's that organizational setup that ensures that actually you could have one ML practitioner assigned to a problem initially to validate that an ML problem is needed, and then as we see more evidence, you add more ML practitioners. Like it requires an organization that believes in this approach.
Thank you so much. And you're very popular. We have lots of questions from the audience. Go right ahead.
Hello, thank you for the talk. The part about the secret to data science being doing as little data science as possible really kind of resonated with me. I was actually saying that the other day in a meeting. But my question relates to MVPs. Specifically, I was hoping you could talk a little bit more about them. At a past company, I tried to do the whole agile thing a little bit at a manufacturing company for ML. And like I made this great MVP, and then I like presented it to stakeholders and they're like, great, this is perfect, we'll run with it. And it's like, no, this is like the buggy MVP thing. But so my question kind of is like, who do you typically talk to in this life cycle of like creating MVPs and all this? And like, how do you like communicate expectations through this life cycle where you're just like, like this is just an MVP, please don't take this as like the end all be all everything.
Oh, yeah. Thanks for that question. So first of all, I hope you ship that MVP to production, because that's kind of the goal. Ship it to production. I think yeah, I think if the stakeholders were excited, that's actually good. Yeah, I think you should ship the model to production. And I didn't want to have this slide to be too detailed, but the other context I was hoping I could share was that the MVP actually plays a very important role. It helps you establish baselines, and baselines are good. Like baselines help you understand, okay, this is the limitation of this MVP. Like we really need to do better because this MVP doesn't work for parents. Or yeah, I'm a parent. I know Spotify doesn't work as well for me because my daughter always listens to my Spotify, messes up my recommendations. So yeah, that's how you make the case. Like I have an hypothesis that if we did this is going to work better for parents in the next iteration. So yeah, ship that MVP and yeah, get the metrics and let the metrics guide your next iteration.
Thank you.
Okay, and then we have one more question from the live audience, and then we'll move on to the Zoom questions.
I have a question with respect to data science and machine learning engineering. So recently we've started studying and we have like machine learning and time series in our course, and in a few months we'll be starting our job search. My question is, what is the key difference in terms of work as a data scientist and as an ML engineer? And what are the key skills that are required in these two, and what distinguishes them?
Yeah, honestly, I don't know. I would say it depends on the company. It really depends on the company. I think I can't remember. I think there was like a popular tweet that was made by someone that that's I'm not sure, I might be misquoting here, that ML engineers just know more software engineer than data scientists. Yeah, I don't know if I would agree. I think I would say that as Spotify in particular, we think about data science as helping us solve, like, so data scientists invest more time in A/B test analysis, and they're more they understand causal inference, and they understand, like, really understand things like metric sensitivity and whether we have the right metrics for our decision making. Yeah, they really help communicate to stakeholders about the impact of all of the investments that Spotify is making. Yeah, and I would say that they have a very strong statistical, like when I see a report made by data scientists, they have really strong statistical understanding. Like I don't believe, like, as a software engineer that came to USF for a 1-year master's, I'm not sure I would be a great data scientist. Yeah, so that's at Spotify though. Meanwhile, ML practitioners oftentimes they understand all the, I would say ML practitioners at Spotify, many of them are possibly great data scientists, but I guess that's a spectrum, how great they are in the actual techniques and understanding statistics, maths, and all of that. But they speak the language effectively. They can read a paper and understand. They might not be the experts, but they really understand how to get those systems working in production, and scaling to Spotify scale. So yeah, but don't quote me. Everyone defines this differently. I've seen more data scientists having experience in statistics, economics, physics. Yeah, don't quote me. Just sharing my experience. I would say look at the company and look at the job description. It will be my tip.
Thank you. Oh, and we do have actually one more question from the audience.
Hi, can you hear me okay?
Yes.
Thank you for your talk. I have one question regarding the heuristics and human in the loop that you were mentioning. I really like that you highlighted that doing a heuristic based model and then having a human in the loop is not wrong. And thank you for highlighting that. I can totally relate. People tend to focus on building ML models. My question is, let's say we want to have a model which depends on heuristics and also has, let's say, human in the loop. How would you consider productionizing it? And the second part is, how do you sell that kind of a model to a stakeholder? Because in my experience, usually stakeholders want something which is ML based or AI based, because that's the buzzword. And convincing that a heuristic based model is not is also similar to an ML model is kind of hard. And I understand that business metrics might help, but I'm not sure if it's convincing enough. So how do you kind of deal with that?
Yeah. Yes. Actually, I've been fortunate to work at a company where we did all of the above. What I'll say is, like, when you're presented with a problem, I almost would start with heuristics. So the company I worked at was a company that it was an NLP problem, and we're trying to, it was on a problem called probabilistic record linkage. We're trying to match link records from data sources that didn't have unique identifiers. And I think this business realized that they needed to have humans in the loop because we didn't even have a labeled data set to start with. So yeah, like sometimes you have really low quality data that you don't even have a labeled data set. So I think in that situation, there's probably some investment in like getting labelers, professional labelers to be the ones making, to be involved in the process of creating these data sets for the teams. And I think if you did that, it's quite easy for you to make the case that how about we just have these people do it in the scenario where it doesn't work. Like we now have a model that works in some scenarios, but doesn't work in other scenarios. And it's really numbers. I didn't have enough time to have visualizations on how you actually use the numbers to make the case, but it's really numbers that make the case. Like if we were to solve this problem with just human in the loop, this is how much it's going to cost. And if we were to have 50% of the decisions made by our model, we're already saving so much money. So yeah, I think the case makes itself, or we could continue working on this for 6 months while we're not having a business. Yeah, I think it's really about using data and using metrics to guide these decisions.
Thank you. Okay, now we're going to start on our questions from the Zoom audience. So the first question is, how did you get your HTML certification?
HTML.
Yeah, I'm not sure if this one is relevant or not, but they
I don't have an HTML certification, but I'm a software engineer, so I hope I could be certified. Yeah.
Life ended life. Our next question, what is the main difference between roles of data engineering and ML engineering?
Oh, yeah. Yes. So I'll say data engineers help. Actually, I used to lead the data engineering team, so I should know the answer to this. So there's first of all, like data engineers think about data collection, data processing, data analysis, and yeah, and at scale. That's what I'll say. And that's their focus. And then ML engineers, hopefully, if you have these are not hard and fast rules. There are many people that wear multiple hats. Yeah, and yeah, I'll say ML practitioners are they over-index more on feature engineering and model development and model evaluation. On ML teams, oftentimes, if you're not wanting to be over-reliant on an ML practitioner, you probably will pair an ML practitioner up with a data engineer, because I'm sure we've all seen, there's this picture of how actually data preparation is a much larger share of the work that is required to ship an ML product. So oftentimes there's more than enough work for a data engineer. In fact, evaluating models, their teams, there's like sometimes you need one person just to evaluate an ML model, because it's like a full-time person just evaluating models, because it requires building data pipelines and understanding and analyzing how the model performs. And oftentimes not like all the business metrics requires lots of data engineering. So I'll say many ML teams have more data engineers than ML practitioners.
Thank you.
Yeah.
And we have one more question from the Zoom audience, and then also more questions from the live audience. So from the Zoom audience, on heuristics versus ML solutions, assuming your heuristics is coming from a domain expert whose expertise you wish to capture into a model before they leave the organization, this person says expire from the organization, what are key questions to ask or decision tree to follow to select a modeling approach? A heuristic path would seem like following the prior 1980s AI approach of expert systems, while an ML approach of today maybe a data capture challenge of the expert?
Yeah, actually, as what I'll say with this question is that as long as the roles are available to you, you actually don't need the experts. Very controversial. If the person managed to hard code all these rules in a system that works, then all you need is model evaluation. I would say just continue to build your models, continue to build a different model variants. So this heuristic system is a model, and then you're building another ML model. So you're trying to understand what are the gaps between these two. And oftentimes, if you could even use that heuristic to create your training data as well. That's actually another approach that I would recommend. If you use the heuristic to create your training data, so it will be the labels for all of your events. Yeah, you will have a model that would recreate the heuristic. I hope, I believe. Yeah.
Thank you. Okay, and then we have another live question.
Hi, Funmi. Thank you for coming and giving a talk. It's really encouraging and empowering as a alumni of our program and also as a woman in tech. It's been a really great talk and our pleasure to have you here. I want to get an advice for our students who just started this program about 5 months ago. Some of them maybe a motivation as a data scientist and also advice for a lot of students who are going to enter as a junior data scientist, and some of the people in this room visiting from other places or on the Zoom audience who is in a maybe early mid-career. Could you give us some advice and tips for developing a successful career? Thank you.
Oh, yeah. Okay. I need to think about this. I don't know. I would say try to work on interesting problems. Yeah, that's worked for me. Try to work on the most interesting problems you can find in your organization. The most challenging, yeah. Let me see if I can give it more advice. Yeah, interesting problems and try to work with the most talented people you can find as well. Yeah, interesting problems, interesting people. They really do level you up. And already, like, go to meetups. I just recently moved to the New York area, and I really miss the SF tech scene. I feel like there was one of the things that was so helpful for me was just meeting people that were practitioners that had done so much in the space, and hearing about their journey. Of course, not two people would have the same journey. Yeah, I think yeah, and just try to find great managers too. That would be my third system, because really a great manager helps you grow. So it's about trying to find a good manager. I could think about more and share offline more tips.
Thank you. That would be great for the students. So yeah, so at this time we have answered all of our questions. So we'd like to thank you again for giving us this talk. And we'd like to thank everyone who came in person and everyone who is online. So thank you so much. Next week, we'll be doing salary prediction with deep neural networks at Glassdoor with Andrew Chamberlain. All right, everyone, we're going to conclude there.
Salary prediction.